You guys have already started graphing exponentials. We kind of get a sneak peek into it yesterday. You guys asked that question on the homework today. So that's kind of, are you done with it? That's kind of where we're going today. We're going to add more detail. We're going to look at the actual properties and other parts of it, like domain and range, and what is called the asymptote. So I'll be able to graph an exponential function from a table and identify that all points along the line are solutions of that equation. So you're going to see a lot of that stuff today. So let's just look at this real quick. The basic function that keeps the same shape of the function is your parent function. When we are talking about lines, remember in lines, the parent was y equals x, right? Which was just up 1 over 1, up 1 over 1, and kind of created that diagonal line. And we did transformations with it, and we compared the line. We said, well, it's more steep or less steep, or it moved up however many or down however many from the parent. So every single function you learn will have a parent. In this case, the parent function is going to be really different almost for every single type of function because it's going to be based on the base. So an exponential parent function is y equals b to the x, and it is actually kind of a family of functions. So all functions with the same b value are a family. So when we go to talk about transformations next week, after we do all this graphing stuff, so we'll talk about transformations, I believe, on the block day next week, we will look at how we're not actually going to have one exact parent function. There's going to be a parent for every different base of b, and that we'll have to compare to. So remember, b is your growth or decay factor, so how much you're multiplying by. If it's growth, your value of b is what? How do you know it's growth? Hannah, what? Greater than 1. How do we know it's decay? Kelly?
It's more than 0 but less than 1.
Yeah, more than 0 but less than 1, so right in between there. So we learned that yesterday, and we'll talk about that stuff a little bit more. But as you notice here, this line here is never, ever, ever going to cross the line, this graph here, and this is what is known as your asymptote. We'll talk more about this throughout the lesson today. This is called an asymptote. So this is y equals 0 in this case. A line that the graph will get very close to, but never touch. And we'll talk about when we get into examples why this is the case. Okay, so that is just some information quickly about exponential graphs. The really important pieces of this graph are that it is a curved graph, and there is always an asymptote, which you do not have with linear graphs. And you'll do a lot with asymptotes in Algebra 2. You'll do vertical and horizontal and stuff like that in Algebra 2. So when you're ready, you guys can flip to the next page. And like I said, I will talk more about that asymptote the rest of the period today. Can you not see anything? Caitlin, what do you need me to read to you? Are you sure? Are you sure? I can read it if you need me to, okay? All right, guys. So let's look at some examples here. So we're going to graph y equals 2 to the x. So the first one we're going to do by hand. The other ones I'm going to have you guys learn to plug them into calculators. So again, if you don't have a calculator out, make sure you have it out. If you do not have one, please raise your hand now so I can get you a calculator before we get to that point. Get a calculator, guys. It's halfway through your freshman year. Does anybody else need one? Okay. So, we've done this before. This first part of the process should not be new to you guys. We've been working on this over the last couple days. So we know we input -2 for x. Jenny, what does a negative exponent mean?
That you have some closure.
So what does that become then?
1/2.
So it's 1/2, and then it's squared, because once you flip it, it changes it from negative to positive. So that means it's 1/2 times 1/2. So Jenny, what's 1/2 times 1/2? And I'm going to say or 0.25 if it's easier for you guys to see things as a decimal, okay? I don't care which way you see it. So this is the ordered pair, -2, 1/4. So on your graph, you would plot the point -2, 1/4. Again, we then substitute -1 in for x. Kelly, what does that -1 mean we do? Oh, wrong Kelly. Sorry, there's a Kelly in front of you. But you're right. Go ahead. Take the reciprocal, and what does that do?
It just make it 1/2.
And it's raised to the what power then?
First.
It's raised to the positive first. So it switches it from negative to positive, which means 1/2 to the first is just 1/2. So that is -1, 1/2. So I take that point and I plot it. Okay, Kelly. Anything to the 0 power is? Huh? What did you guys learn from the last couple days? Anything to the 0 power is 1. It's always 1. So that's going to be 1 there. So that's 0, 1. And we talked about why that was over the last couple days. Bless you. Okay, Avery, 2 to the first. Madison, what's 2 to the second? Good, which means 2 times 2, which is 4. So that's 2, 4. So we plot all of our points. And we'll talk about the connection of them in just a second. But let's first talk about something here. So you should notice that each one of these is multiplying by 2. Do you guys see that on the x, that it's multiplying by 2 each time? Does anybody not see that? So if we go backwards, it's dividing by 2. Do you agree with that? Okay, so 1/4 or multiplying by 1/2. So I'm going to do this on the board. You guys don't have to write this out. So if I take 1/4 and I multiply it by 1/2, I get 1/8. So that would be -3, 1/8, right? If I take 1/8 and multiply it by 1/2, I get 1/16. If I take 1/16 and multiply it by 1/2, I get 1/32. If I take 1/32 and multiply it by 1/2, I get 1/64. If I take that and multiply it by 1/2, I get 1/128. Will I ever reach 0 if I keep multiplying by 1/2? No. What's the only way you can make a number become 0? What do you have to multiply it by? 0. So multiplying it by 1/2 or 2 will never make it become 0, will it? So that's why you have what is called an asymptote. So we're going to draw the line of the asymptote in here before we connect the points. The asymptote is the line that it will never touch. It's going to ride along it, but it will never touch. So this is your asymptote here. And it's at y equals 0. So that way when you go to connect your points, you know exactly where you should not cross. I'm having issues connecting the points here. So you know exactly where your curve should not cross if you draw that equation of the asymptote in. So the asymptote is a horizontal line. So it's a y equals equation. So the asymptote is y equals 0. So draw the asymptote in, please. Some of you have not drawn your asymptote in. Draw a horizontal line so you know that's the line. And the asymptote is y equals 0. Where do we get this asymptote from? Notice there's nothing added to the end of our function, is there? You guys see how there's nothing added to the end of our function? So our asymptote is not always going to be at 0. It depends on what's added there. So the asymptote is what is added to the end. Okay, so now we're going to talk about domain and range. You guys know domain and range. Domain relates to which value? What value, Alexis, does domain relate to? X, very good. So X is read left, comma, right. So we're going to do an interval from left to right. So Alexis, help me out. If we're following this graph to the left, what's going to keep happening? What? So what is forever in the left direction? Good. Okay, this graph is going to shoot off, but it's still going to come out. It's just going to come out like higher up this way. So what's going to happen in the right direction? Positive infinity. So we have a negative infinity to positive infinity domain. It's going to go on forever to the left to the right. So we're saying every single number will be reached on the x because forever to the left and forever to the right is happening. What questions do you have about the domain? Yes, Jenny.
When is it going to be like the normal domain?
What do you mean by the normal domain? Like listing out points?
Yeah.
That won't happen very much anymore in your high school career.
I like that one better.
It's a little bit easier, that's why. But that doesn't happen much because when we're dealing with lines that are connected, you have to get every single point in between, and you can't do that with you could, but you would be there for the rest of your life. So that's why you don't really want to do that. Okay, Alex, range relates to? So it's your down, comma, up. What is your lowest point, Alex, on the down part? How far down will this go down on the y? How far down will this go on the y?
-7.
So you see a point here at -7. There's a graph down here.
Oh, no.
Infinity implies it's going down forever, so we have to be careful. It's not going down forever, is it?
No, because it doesn't pass
It doesn't pass this line. What is this line at, Alex?
0.
0. Will it ever reach 0, though? Didn't we just discuss that it won't reach 0? So we can't include 0, so we use a round bracket. Remember the parenthesis, the round, means not included, and the bracket, the square, means included. 0 is not included. Remember I did all that work over here that said we're never going to do that if we're going to multiply by 2 constantly. So, Alex, what is the up value? What is the farthest up value? So this graph is going to go up forever, so it's infinity. Very good. Okay, then it asks, is 416 on the graph? All you need to do here is plug in 4 for x. So that's 2 times 2 times 2 times 2. And that is 16. Did you output 16 when that happened? So yes, because when you input 4, $16 comes out. So if we do this one, y equals 2 to the second, which is 2 times 2, which equals 4. So no, because 4 is not the same thing as -5. So no. The output for 2 should be 4. I'm sorry, yes, the output for 2 should be 4. Okay, so look at this graph, look at this first example, and tell me if you have any questions for me, please, before we move on to the next one. In the next one, I'm going to start showing you guys how to use your calculators. I don't care if you do it by hand or with a calculator. Some of your calculators, like this one here, are not as easy to use as the others. I think most of you, hold up your calculators really quickly. So Hannah, yours will be a little bit harder to use too, okay? So I'll make sure that I work with you guys as well when we're doing that stuff. Again, you can always do things by hand as well. I just want to give you guys the option to also use your calculators. Okay, so we're going to graph this one here. Y equals 1/2 to the x. So we are going to work on plugging this into our calculator. So in your calculator, you are going to plug in 1/2 to the -2nd. So here's how this is going to work for most of you guys. Most of you guys are going to write in your calculator, besides I think Hannah and Jill, just wait a second. So there is a parenthesis there, so you're going to hit your parenthesis button, hit the 1 button, hit the ABC button, 2 button, and then close your parentheses. So some of you guys have different options from here. Some of you guys will have like a caret to use for an exponent. Others of you have like this box thing that looks like this, I think. Right? So you'll hit that button to create the fraction. And that's exactly what we're doing. I'm literally just writing what you're typing into your calculator. Yeah. So then you hit your negative button, not the subtraction button, negative, which I think has the parenthesis around it on your calculators. And then you type in the number. All right, so go ahead and type that in and make sure you get 4 out. You should get 4 out. If you don't get 4 out, you did something wrong. So raise your hand. Raise it with the caret button. You do have an AB. You have it. There's other buttons there too that you could have. Negative. And then 2. Raise your hand if you need me. I'm gonna see if you girls did you figure it out?
No.
Hannah and Jill, see if you can figure it out. And if you can't, raise your hand. Okay? It's pretty similar. You didn't close your parenthesis correctly. That's a comma. Where's your delete button? Okay, close the parenthesis.
No.
Do you see this button here? That's what you're going to use for an exponent, okay? What's wrong? You didn't get 4?
I'm just really confused here. I got 2.
So, parenthesis. 1/2, 1 ABC 2. Close the parenthesis. Raise it to a power. And then type -2 in. Enter.
What do I do after this?
You'll raise yours to a power using... Where is your power? This one here. And then you'll just type -2.
Oh, is it not the exponent?
It is, you're fine now, hit enter.
No.
You're good.
I thought for the exponent you do that.
You have that X to the blank box there, Jenny. Not the X, no. Keep going over in that row, keep that one, yes. I'm coming, guys. When you're done with that, plug in the other numbers. When you're done with that, plug in the other numbers. You have to work backwards. 1, ABC 2, and then that, well, so hit, let me see this. Hit parentheses, and then you'll do 1 ABC 2, okay? And then you'll hit your Y to the X button, okay? And you'll type 2 negative, and then it will go there, okay? It's really confusing on these ones. I'm telling you, these ones are hard because you can't type it all in at once. So parentheses, 1, ABC 2, Y to the X, 2 negative. You have to do the negative sign backwards. It's so weird. I know.
Okay.
If you get one of those ones, it's a lot easier. Did you figure it out or no? So you're gonna hit this button first, so it puts the parentheses around it.
Yeah.
So you do 1, A, B, C, 2. Okay. This Y to the X button raises it to a power.
Oh, I
then
was
you-
doing this one.
Yeah, and then you have to do 2, and then you type the negative in, and then you got it.
Okay.
Okay, get the rest of your table done, please, with your calculator. So parenthesis. 1. You have the fraction button, so hit the fraction button. 2. Close your parenthesis. And then, where's yours? So raise it with that, that's the exponent, and then type -2 and close that parenthesis. And then close the parenthesis and hit enter. Okay? Alright, so continue your table. I'm going to put the answers up here. You guys should be doing your table on your own using your calculator. And if you do not have something correct based on what I have on my table, you need to let me know so that I can help you do things correctly.
Like on the test, do we always have to show the work?
You should always show the work if you...
I mean, if I enter the calculator that.
Yeah, I mean, it's good to show the work, though, so I can give you partial credit if you do things wrong. Okay, look. Don't just copy my table. Actually try it. Don't just copy my table. Actually try it. Did anybody not get the values that I just outputted? Did anybody not get the values that I outputted? I just did it in my head.
Because so I redid this to see if I like understood it, and I got like a weird sign. Like I did the exact same one you did.
So you're going to do the parenthesis button. 1, A, B, C. I'm just going to use these numbers 2. And then you're going to use the Y to the X button. You're going to hit 2 and then the negative button.
Okay.
Okay, so that's it. Yours is actually a plus minus button. So I'll type it write it that way. It looks like this. It like switches it. Okay? So that's how you'll type it. So try typing it that way. See if that makes sense. Other people not get those numbers. Okay, so once you have that there, notice that there is nothing added at the end of this, so your asymptote here is at 0, meaning we will never cross 0 because you're adding nothing to the end. So y equals 0 is our asymptote. So I'm going to draw that in first so that I do not cross it. And then go ahead and plot your points. Did it work?
Yeah.
Okay. Anybody else still need me? And then that curve will go on forever. All right, so get your graphs plotted and connected and let me know if you have questions before we answer all of the other ones. You did figure it out?
Yeah, I got it.
Sure, good. All right, let's start with the... Do you need to get water? Okay. Let's start with the domain, which is x, and it's left to right. Carly, what do you notice about our domain on this one?
It goes.
Carly?
I thought you just said for the class.
No.
Somebody else answered.
She was thinking, I'm pretty sure. So what do you notice about the domain? Will it go on to the left forever? Yes. So that is what?
Negative. Negative.
Negative what? Good. And does it go on to the right forever? So that's negative infinity to infinity. Very good. Mackenzie, Range is y down to up. Will it go down forever? No, what is the point? What is the line that it stops at? 0. You will always have your, part of your range will always be your asymptote because you're never going to reach that. So that's how you know your range is your asymptote. So we'll go up forever. So that is what then, Mackenzie? All right. When we just check to see if points are on the graph, we just plug them in. And you can just use your calculators for this too. So 1/2 to the 4th power is 1/16. If you plug that in, try it. Try to do 1/2 to the 4th power in your calculator and see if you get 1/16. You probably get a decimal. I don't know what the decimal is of 1/16. Somebody do 1/16 for me as a decimal so I know. It's 0.0625. So is 0.0625 the same thing as 16? Yes, it is. 0.0625. No, okay. So no, 1/16 is not the same as 16, right? It does not equal 16. Okay, plug in 1/2 to the -2nd and you get 4. Is that what we wanted? Yeah. So, yes, because, I need to change my color so it doesn't go in there. When you input -2, your output is 4. Okay, what questions do you guys have before we move on to the next slide? We can start moving a little bit quicker through it. Obviously, if you have any calculator questions at any point throughout this, let me know. Yes, because when you input -2, your output is 4. Ren, you ready? Just flip to the back if you want to start trying this. Hannah and Jill, let me help you out with your calculators in a second here. For those of you guys that are starting to work on this one, you can type this into your calculator all at once, unless you're Hannah and Jill. So you can literally type in 3 to the -2nd minus 1. You guys can do that in your calculator. You two, on the other hand, will not be able to do that. So you're going to do the same steps you did at the beginning for the last one. So start with the 3 to the power. So go ahead and do 3 to the -2nd in your calculators, girls. And hit equals once you got that. And you should get like 0.1 repeated, I'm pretty sure.
I got -8 over 9.
Just 1 second. You're fine. You're probably right. Just 1 second. Okay, then subtract 1. Then do -1. Do -1. Minus, yeah. Okay. So you can just round to 2 decimal places. You can round to 2 decimal places. I'm pretty sure it's -0.89. Yeah. If you do 8 over 9 in your calculator, did you guys get -0.89?
Yeah.
Okay, so keep going through there. Those of you that did not get that, let me know now that you're not understanding how to use your calculator so you don't go home and do it wrong. Why did that happen? Oh, you have a fix on. Let me see. How do I change that off? Okay, try it again. You had it rounding it up every single time. Try it again and see if it works. Yeah.
This right?
-8 over 9, yeah. That's another fraction for it. So, or -8 over 9 is fine. I'll write both the fraction and the decimal up here while I'm doing this. I'm going to write the answers up as you're working. So that's -2/3 or 0.67. So this one should be -1. Wait, no. That should be 0. 2 and 8. So look at your table. See if your tables match mine. Go ahead and see if your tables match mine. Does anybody's table not match mine and you need some help?
I got like whole numbers for all of them. So
I don't know what this M1 is. Usually there's a receipt on the back. You got this for the first one though, didn't you?
yeah.
So you did, maybe it's fine. So you typed in 3 y to the x 1 negative equals, right?
Yeah.
And then you subtract 1, and that's that. You should get whole numbers for the rest of them. The only one I got decimals for were the first 2.
Yeah, and then I got like 10 for the next one.
Okay, try it again and see if you still get that. Anybody else? Okay, go ahead and plot your, wait, where's our asymptote? Who can tell me where is it?
Negative.
It's -1. Our asymptote has moved. We're never going to cross -1. So this time our asymptote is at y equals -1. So I'm going to draw a horizontal line through -1 that I'm never, ever, ever going to cross. So then I'm going to plot my points. And it looks like this. All right. Morgan, what is my domain on this one? Left to right. Yes, you should notice that our domain has always been -infinity to +infinity. That is not going to change. Your domain will always be -infinity to +infinity. So that shouldn't be a hard one to get correct. Your range will change though. What is my range on this one, Katie? It will never reach -1. So it always goes from your asymptote to infinity or -infinity to your asymptote. Your asymptote is always a part of your range. So you guys are aware it's never going to cross that asymptote. That's why it does that. So Katie said, well, y equals -1 is where it's never going to cross. So that's my low point, and it goes up forever. Okay, so then I substitute in 3. And I get 27 minus 1, which is 26. So is that on your graph? No, 26 does not equal 27. All right. So go ahead and get that copied down. We're going to skip the next example and go to the last page. So once you have it copied down, just flip your packet. The other stuff is recap stuff, and it's not a huge deal if we don't get to that, but I want to do one with a number out front so you guys know how to plug that into your calculators. Jenny.
Like, if you have a fraction in your numerator and you have to change it to, so it can be 3.
No, you can type it exactly how you see it. So in your calculator, you would just type that parentheses, 1/3, parentheses, -2, plus 2. Okay? Guys, when you guys go to type stuff in your calculator, you're typing exactly how you see it. So we're going to skip this one, and we're going on to the next one here, so we can do this one. So go ahead and start typing into your calculators and seeing if you get the same outputs as me. The first output, just so you guys are aware, should be 2/9. So I'm going to have that there for you. Hannah? And Jill, you're going to do the exponent first. So you'll do 3 to the negative second, okay? And hit equals. And then multiply it by 2. And then 2 over 9 is 0.2. Repeat it, so you're fine. So I think that's 0.222 right there. You can for this one, for you. Okay. Okay. That's fine. Sometimes it works that way and sometimes it doesn't with those calculators. So you have to be very careful. Yeah.
How do you know what you're going to do with your calculator each time? Like, how do you know what you're going to type in each time?
You use this equation, the equation given to you.
Oh, okay.
And then you just substitute those values in.
Okay.
So guys, the equation given to you is the equation you're typing into your calculator every single time with the substitution of the x values. Jacqueline, get the rest of your table done. Guys, get your table done before I get it done so that you guys know if you're understanding it or not before you leave my room. So that's 2/3 or 0.67. Before you plot your points, make sure your table matches my table. So when you plug in 0, you should have gotten 2. If you didn't get 2, let me know. If you're having issues with your calculator, let me know. So that one should be 6. Oh, thank you. Oh, I multiplied by... You didn't... Why'd you change that to a 1?
Oh.
If you're not getting the right numbers, please, please, please let me know. So we have 2 times 3 to the second, which is 18. So plot the points. But first, Jill, where's my asymptote? Is there anything added at the end? No, so my asymptote is at 0. So we're never going to cross 0 on this one. So we'll always plot our asymptote first, so we know exactly what we're not going to cross. Only plot the points that fit on the graph. That doesn't mean that there's not other points along this line, this curve. Okay, Ab, what is the domain? Two. It will always be that way because it's always going to run from the left to the right. So that's always going to be the case. Jacqueline, what is my range? Yes, it started at it will never cross your asymptote, so it will never go below the asymptote. We can't include our asymptote because it won't cross it. And it goes up forever. And then I plug in -4. And it equals 2 over 81. Is 2 over 81 the same as 17? All right. So, what questions do you guys have for me